1. Ordovician Gamma Ray Burst. Let's talk about the most lethal beam of light ever recorded. Roughly 445 million years ago, a massive star in our galactic neighborhood collapsed into a black hole, firing a colossal jet of high-energy radiation directly toward Earth. It formed in a distant, dense star-forming region, but the beam traveled across the cosmic void with pinpoint accuracy. Imagine a laser pointer beam hitting a target from across the ocean. This was the celestial equivalent, though far more destructive. It scorched our atmosphere, stripping away the ozone layer like peeling paint off a house. To visualize its scale, imagine a beam of light as thin as a single human hair, but spanning the entire length of the Milky Way. It didn't have a color you could see with your eyes, as it was pure, invisible gamma radiation. Its texture, if you could touch it, would feel like a burning, high-frequency static that vibrates the very atoms of the air. It was a silent, invisible titan of pure energy. The real power is in its absolute lack of physical mass. It is pure, unadulterated energy moving at the speed of light. It carries the capacity to ignite the upper atmosphere, turning nitrogen into brown nitrogen dioxide smog. It is less like a solid object and more like a permanent, invisible storm that never stops raining radiation. The danger, when toned down for humans, is like standing too close to a heat lamp at a buffet. It feels a bit warm, maybe a little drying to your skin. But when it hits the planetary scale, it becomes terrifying. It acts as a global sterilizer. It attacks the very foundation of the food chain, specifically the phytoplankton in the oceans, which struggle to survive under the sudden, massive influx of ultraviolet light. It doesn't just pass by, it waits for you in the upper atmosphere, lingering as a layer of toxic, smog-filled air that blocks the sun and plunges the planet into a sudden, deep freeze. It inflicts damage by shredding DNA. It chases down every living organism, ambushing the immune systems of complex life. It attacks the atmosphere until the sky itself becomes a hazard. It waits for the ozone layer to recover, but since the radiation persists, the recovery never comes. Nature endures a brutal test, as the entire planet is essentially pushed into a pressure cooker of high-energy particles, forcing life to hide in the deep, dark crevices of the ocean just to avoid the surface bombardment. The bizarre, unexpected behavior here is that the radiation didn't kill everything instantly. Instead, it triggered a massive, global cooling event. By creating that thick, brown nitrogen dioxide layer, it essentially put the Earth in a cryogenic chamber. The very thing that scorched the sky ended up freezing the ground, showing that sometimes the most dangerous things in the universe work in completely paradoxical ways. The next one is even closer and hit us with a radioactive wave that would make a modern city feel like a battery running out of juice. 2. Pleistocene Supernova. Let's talk about a star that decided to go out with a bang just as our early ancestors were beginning to thrive. About 2.6 million years ago, a massive star in the Scorpio-Centaurus association detonated. It formed roughly 150 light-years away, close enough to effectively bathe our planet in a torrent of cosmic rays. It was a celestial fireworks display that didn't stop for hundreds of years. Think of the size of this event by imagining an entire city skyline exploding all at once, but with the brightness of a billion suns. It appeared as a brilliant, unblinking light in the night sky, perhaps even brighter than the full moon, casting a weird, unnatural glow across the landscape. Its texture, if you could perceive it, would be like a shower of sharp, energetic sand, a relentless rain of particles hitting the atmosphere. Surprisingly, the power is in its ability to stay relevant for centuries. While the explosion itself was a singular event, the aftermath, the wave of cosmic rays, dragged on for hundreds of thousands of years. It didn't just flash and fade, it turned the sky into a long-term cosmic particle accelerator. The danger, toned down, is like having a slightly bright nightlight on in your bedroom that you can't quite turn off. It's annoying, it disrupts your sleep, and it's just a little bit out of place. But when this event happens on a cosmic scale, it's a systematic assault on the atmosphere. It ionizes the air, changing how lightning behaves and potentially increasing the frequency of storm activity. It creates a persistent, glowing aurora that would have been visible even at the equator, a haunting, permanent light show that never let the darkness settle. It causes damage by altering the climate. It attacks the biological rhythm of the planet. It chases the stability of the magnetosphere, ambushing the upper atmosphere with high-energy muons that can penetrate deep into the ground. It waits for the planet to try and return to normal, only to hit it with another wave of radiation. Nature endures a long, slow squeeze as the cosmic rays change the chemical composition of the atmosphere, affecting everything from cloud formation to the growth of vegetation. The bizarre twist is that this supernova might have influenced human evolution. By forcing large mammals to adapt to rapidly changing weather patterns and higher levels of background radiation, it may have nudged our ancestors toward smarter, more adaptive behaviors. It was a violent, unasked-for experiment on the cradle of humanity. The next one is even more dramatic, involving a visitor from the outer reaches of the solar system. 3. Younger Dryas Comet Airburst. Let's talk about the day the sky decided to shatter. Roughly 12,800 years ago, a massive comet, or perhaps a fragmented cluster of icy bodies, entered the inner solar system and slammed into the atmosphere over North America. It formed in the cold, dark outskirts of the Oort cloud, hurtling toward the sun before being pulled into our path. This wasn't a single strike but a shotgun blast of debris that devastated the northern hemisphere. Picture the size of this event by imagining a skyscraper-sized boulder, but multiplied into thousands of smaller pieces that fill the sky. It appeared as a series of blinding, multicolored streaks that turned the day into a nightmare of fire. The texture was essentially a chaotic mix of ice, rock, and superheated vapor, creating a wall of heat that expanded outward with the force of millions of atomic bombs. The real power is in the atmospheric pressure wave. Surprisingly, this power isn't just about the impact on the ground. It's about the displacement of the air. It creates a shock wave that travels for thousands of miles, flattening everything in its path like a giant cosmic bulldozer. It's an engine of pure kinetic destruction that doesn't need to hit the ground to level a forest. The danger, toned down, is like standing in the middle of a windstorm where you have to hold onto a railing to keep your balance. A bit blustery, maybe a little loud. But on the scale of a comet airburst, that wind becomes a literal wall of fire. It rips trees out by the roots, superheats the oxygen, and ignites everything combustible. It's terrifying because it comes from above with no warning, a sudden, searing gust that turns a quiet landscape into an instant furnace. It causes damage by kinetic force and intense thermal radiation. It chases the horizon, ambushing forests and plains alike. It attacks the very air you breathe, replacing oxygen with superheated nitrogen and carbon monoxide. It waits for the initial explosion to settle, then unleashes a secondary wave of fire and dust that can choke a continent. Nature endures a sudden, violent reset, as entire ecosystems are vaporized, leaving nothing behind but a layer of nanodiamonds and soot in the geological record. The most bizarre thing? It triggered a 1,000-year cold snap known as the Younger Dryas. A massive warming trend was suddenly reversed by the cooling effect of the dust blocking out the sun. It's a tragic irony that a fireball from space ultimately threw the world back into a deep, icy freeze. The next one is even more mysterious and persistent. 4. Pliocene Cosmic Dust Cloud. Let's talk about the slow-motion siege that lasted for ages. About 3 million years ago, our solar system wandered into a dense, dusty region of space, likely the remnants of an ancient, nearby supernova or a dark nebula. It formed deep in the interstellar medium, a vast, murky cloud of gas and grit. As we drifted into it, the solar system essentially drove into a thick, permanent storm of microscopic debris. Imagine the size of this cloud as an endless, featureless fog, but one that stretches across trillions of miles. It would have looked like a dimming of the stars, a subtle, ethereal veil covering the familiar constellations. Its texture was like ultra-fine sandpaper, so small you couldn't feel it individually, but collectively it was a grinding force that abraded the outer reaches of the heliosphere. Surprisingly, the power is in the erosion. This cloud acted like a slow-motion sandblaster on our protective bubble, the heliosphere, which shields us from the worst of interstellar space. It's an endurance test for the sun, wearing down our defenses bit by bit over millions of years. It doesn't move with speed, but it moves with inevitable, crushing pressure. The danger, toned down, is like driving through a dusty road where you have to clean your windshield every few minutes. A little bit of dust, a little bit of trouble. But in space, that dust is moving at incredible speeds. It penetrates the solar system, flooding the planets with cosmic rays and changing the balance of the atmosphere. It's terrifying because you can't see it coming, and once you're in it, there's no way to turn around. It just sits there, a permanent, suffocating blanket of cosmic interference. It causes damage by dampening the solar wind. It chases away the protection we usually enjoy from the sun's magnetic field, ambushing the Earth with increased radiation. It attacks our climate by altering the amount of solar energy that reaches the surface, causing slow but steady changes to ocean temperatures and weather patterns. It waits for millions of years, slowly grinding down the status quo of the planet's environment. Nature endures a long, slow period of instability where the weather never quite feels right, and the stars themselves seem a little dimmer. The most unexpected behavior is that this cloud might have contributed to the drying of the climate in Africa, which was a major factor in the transition to more open grasslands. Without that dust, the world might look completely different today. Before we move on to the next one, here is your mid-video challenge. 5. Solar flare of 774 AD. Let's talk about the day the world got a massive, invisible shock. In 774 AD, a colossal solar flare erupted from the sun, far more powerful than anything we've seen in modern times. It formed right on the surface of our host star, a chaotic explosion of magnetic energy that threw a wave of charged particles directly toward us. It was a quiet disaster, as there were no satellites or power grids to fry, just an unsuspecting world beneath a beautiful, haunting aurora. Imagine the size of this flare as a ripple in a pond, but the pond is the entire solar system and the ripple is made of high-energy particles. It would have appeared as a massive, shimmering curtain of green and red across the entire sky, even in places where you never see auroras. It had no texture, but it felt like a static charge in the air, a hum that resonated deep in the bones of anything sensitive to magnetic fields. The real power is in its electromagnetic pulse. It's a silent, invisible surge that can rewrite the electrical conductivity of the ionosphere. It isn't a physical blow, but a massive jolt that ignores the ground and targets the very wires of the atmosphere. It is the ultimate electronic disruptor. The danger, toned down, is like the slight static shock you get when you touch a doorknob on a cold, dry day. A quick snap, a little bit of surprise. But on this scale, it's a global power outage that would last for months, maybe years, if it happened today. It attacks the infrastructure that holds our world together. It doesn't just pass by, it waits for our technology to reach a certain level, then strikes with a force that could plunge humanity back into the Dark Ages. It causes damage by inducing massive currents in conductors. It chases every wire, every circuit, and every piece of technology, ambushing the global power grid. It attacks the satellites that provide our communication and GPS. It waits for the perfect moment to discharge its energy into the planet's magnetic field. Nature endures the influx of radiation, which is recorded in the tree rings of ancient oaks as a massive spike in carbon-14. A permanent scar in the wood that tells us exactly when the sun lost its temper. The bizarre twist is that we only know about this because of those tree rings. There were no written accounts of the event itself, just the silent, chemical record left in the cells of trees that were alive at the time. It is a mystery written in wood, a reminder that the sun has a history of violence we're only just beginning to uncover. The next one is even more intense and would make our modern electronics look like toys. 6. Carrington Prehistoric Event. Let's talk about the ancestor of all solar superstorms. Before the 1859 Carrington event that we know about, there was a prehistoric precursor that dwarfed it entirely. It formed as a massive, unstable region on the sun, releasing a coronal mass ejection of such immense size that it would have permanently altered the magnetosphere if it hit today. Think of the size of this event as being equivalent to a solar wave as wide as the planet Jupiter. It would have appeared as a blinding white flare on the surface of the sun, followed by auroras that stretched from the poles down to the equator. Its texture would be like a blinding, burning wave of pure magnetic interference. Surprisingly, the power is in the compression. It hits the magnetosphere with such force that it compresses our protective shield against the surface of the planet. It's an incredible act of celestial bullying, pushing our own magnetic field around like it doesn't even exist. It is a show of force that reminds us who is really in charge of our neighborhood. The danger, toned down, is like standing next to a loudspeaker that's turned up just a bit too high. The vibrations make your teeth rattle. A little uncomfortable, but nothing permanent. But for a civilization hooked on electricity, this is the end of the world as we know it. It causes widespread fires, melts transformers, and fries the global communication network. It's terrifying because it is so fast, you wouldn't even know it was happening until the lights went out and the transformers started exploding. It causes damage by inducing massive voltage spikes. It chases electricity through every copper wire, ambushing the grid and attacking every electronic device. It waits for the solar storm to peak and then delivers the final blow to our technological stability. Nature endures the surge as animals, especially those sensitive to magnetic fields, are left disoriented and confused. It's a chaotic, electric assault on the very systems we've built to escape nature's volatility. The most unexpected behavior is that this event could cause auroral currents that would flow through the Earth's crust itself. You wouldn't need a wire to have a problem. The ground beneath your feet could literally become a conductor for the storm. It's a mind-bending idea that the very rock of the Earth could hum with the energy of the sun. The next one is even more massive and involves a bombardment from the deep reaches of space. 7. Cretaceous Meteor Shower. Let's talk about the time the Earth was pelted by a relentless storm of fire. Roughly 66 million years ago, a massive asteroid impact, the famous one, was actually accompanied by a prolonged period of meteor showers. It formed from the debris of a larger collision in the asteroid belt, a cloud of rocks that followed the primary impactor toward the inner solar system. Imagine the size of these meteors as being like a fleet of school buses, but moving at 20 times the speed of sound. They would have appeared as a constant, flickering rain of fire that turned the night sky into a continuous daylight of falling stars. Their texture, if you could hold one, would be a jagged, burnt rock, scarred by the extreme heat of atmospheric entry. The real power is in the sheer volume of impacts. It's not about one giant hit, it's about the constant, overwhelming noise of thousands of smaller strikes. It's a relentless, non-stop bombardment that prevents any recovery, turning the entire planet into a shooting gallery where there is literally nowhere to hide. The danger, toned down, is like playing a game of dodgeball where the balls never stop coming. A bit exhausting, maybe you get hit once or twice, but nothing major. But these aren't rubber balls, they are kinetic missiles. Each one packs the punch of a conventional explosive, and together they create a constant, rattling drumbeat of destruction across the continents. It's terrifying because it is so pervasive, you can't find a safe spot because the sky itself is falling everywhere at once. It causes damage by shattering the crust and kicking up enough dust to block the sun for years. It chases away the life that survived the primary impact, ambushing the survivors and attacking the food sources that remained. It waits for the dust to settle, then hits again, turning the landscape into a post-apocalyptic ruin. Nature endures a brutal, unending assault that forces life to scramble, hide, and ultimately change or die out. The most bizarre twist is that this wasn't just a random act of violence, it was a cosmic chain reaction. One big rock broke up, and the fragments created a multi-generational crisis that lasted far longer than just the day of the impact. It shows that even in the vastness of space, the ripples of a single event can last for centuries. The next one is the final boss of our list, a true titan of disaster. 8. Paleocene Asteroid Storm. Let's talk about the most catastrophic, sustained event in Earth's recent geological history. During the Paleocene, around 56 million years ago, the planet was subjected to a series of asteroid impacts that lasted for tens of thousands of years. It formed from the collapse of a large, unstable cluster of asteroids in the main belt, creating a long-term stream of destruction that Earth happened to drift through. Visualize this storm by imagining an entire mountain range being pulverized into dust and scattered across the solar system, with Earth essentially driving through the debris field. It would have looked like a constant, shimmering aurora of dust and fire, a visual display so intense that it would have made day look like dusk for generations. The texture was essentially a fine, sharp grit that hung in the atmosphere and coated the entire planet. Surprisingly, the power is in the collective heat. While each individual asteroid was relatively small, the combined effect of thousands of impacts created a persistent, massive greenhouse effect. It's an engine of thermal runaway that slowly, methodically, cooked the planet from the inside out. It is the ultimate slow-burn disaster. The danger, toned down, is like sitting in a hot car on a sunny day with the windows rolled up just an inch. A little bit of stuffiness, a little bit of discomfort. But on a planetary scale, this resulted in the Paleocene thermal maximum, a period of extreme global warming. It is terrifying because it is inescapable. It doesn't just hit a city, it changes the entire global climate, raising temperatures by several degrees and acidifying the oceans. It causes damage by dumping massive amounts of carbon into the atmosphere. It chases the stability of the climate, ambushing the ecosystems that were perfectly adapted to a cooler world. It attacks the food chain by changing the ocean chemistry and altering the rainfall patterns. It waits for the planet to recover, then delivers another strike to keep the heat rising. Nature endures a long, miserable slog, with many species dying out simply because they couldn't handle the heat that lasted for thousands of years. The bizarre, unexpected behavior is that this disaster, while incredibly destructive, also triggered a massive explosion of new life. As the old, cold-adapted species died off, it created an ecological vacuum that allowed mammals, including our own ancestors, to evolve and diversify in ways that were previously impossible. It was a hellish beginning to the age of mammals, proving that even the most brutal catastrophes can be the starting point for a new chapter of existence.